Okay, guys, this is the answer key to the Unit P Precalculus practice test. Just a reminder that for this test, it's going to be for function only, so there's going to be no graphing calculator on this test. Okay. All right, we're going to go get started. So again, the best way you can study is by using this practice test, and then just making sure you've done all the delta, obviously, and then like going to do the questions and the delta that you don't feel good about, right? If you didn't feel strong about it, go do it again. Okay. But these are like, also this test is not necessarily how long the practice test is. I'm just emphasizing some concepts that I want you to really focus on. Okay. Okay. Read the following statement and write inequality notation, interval notation, then sketch the number line. This was the first check-in. It was exactly like this, but it's a different statement here. X is greater than 3 or less than or equal to negative 10. Okay, let's just write it as we read it. X is greater than 3, okay? X is greater than 3 or less than or equal to negative 10. So greater than goes together, and then less than or equal to goes together. But or indicates that these are two separate inequalities. So or x is less than or equal to negative 10 would be inequality notation. Okay, if it said and here, then you would write and, right? If it was an or, it's an or. If it's and. Another option is to write it as just one inequality if it's and. But if you have an or statement, you should have two separate inequalities. So interval notation, remember we go from low to high. Infinity is always open. So we have negative infinity up into negative 10, inclusive because it's equal to. Then we've got our union for the or, and then from 3 to infinity. Not inclusive because 3 is just greater than. Number line, sketch, we can just write negative 10, and a 3, and then arrows either way. Okay? Really, really important. Comes up all the time. Comes up this year. You guys, you gotta have these down, the notation down, like fluent. Okay. Simplify the expression using, both of these are the same kind of question. You're gonna see something like this on the test, guys. Exponents, you gotta have them down. Okay. 2a to the 5th over 3a to the negative 5th, all to the 4th. So that's the same. Let's just keep the numerator the same right now. It's 2a to the 5th, and then on the bottom we're gonna multiply. So we're gonna have 3a to the negative 20. And then we can subtract, because it's the same base, we can subtract. So we'll have negative 2, 5 minus negative 20, a to the 25th over 3. And that's it for that one. For this one, numerator I can't do much with. The denominator, we have to apply this exponent to every single term in this product. Okay? So on top, 6h to the 10, u to the 4, all over negative 2 to the 3rd. That's negative 8. I'm going to write it out one step at a time. So that's negative 2 to the 3rd, h to the negative 12, u to the 9. And then we'll combine what we can combine. So look, 10 minus negative 12, that's 6h to the 22. And then u to the 4, 4 minus 9 is u to the negative 5th. All over, and we said before, negative 2 to the 3rd. That's negative 2 times negative 2 times negative 2, that's negative 8. Okay, so making sure we have positive exponents and make sure we're simplifying as much as we can. Both 6 and 8 are divisible by 2, so that's going to be 3 over negative 4. h to the 22, I can't do anything with that, so it's going to stay. But then this I can make positive by moving it to the denominator. So there it is. Okay. All right. We have a sort of a rational equation here. So we have these denominators, 12 and 3. For these problems, you may solve it a different way, but the way that I would encourage you to solve it is to multiply by the least common multiple. Okay, so that's the number that all the denominators go into, if that makes sense. Sometimes you can get that by just multiplying the denominators together, but in this case, if we look, this number is 12. Does 3 also go into 12? Yes. So our least common multiple in this situation is just 12. what we do is we multiply the entire left side and the entire right side by 12, okay? And we just multiply it straight through. So, you know what, I'm going to take my time, I'm going to write it clean. So we have 12, and then x plus 5 over 12, plus, and then another 12, right, we're distributing that 12, x plus 7 over 3 equals 4 times 12. Okay, so what happens here? Well, these cancel, which is x plus 5. This will simplify, right? 12 divided by 3 is really a 4, so this is really plus 4 times x plus 7, and then 4 times 12 is 48. Now we just have like a regular, like kind of multi-step equation, right? So we're going to distribute combine terms. There we go. X plus 5 plus 4x plus 28 equals 48. 5, that's 5x. I'm combining like terms. Plus 33 equals 48. Less 33 from both sides. And so we have 5x equals 15. Divided by 5, x equals 3. Okay? And again, you can always go back and check this by plugging it in. Okay? Alright. Moving on. There goes some graphing here. We have a line segment with two endpoints. Plot the endpoints in the coordinate plane below. Okay, so this should be pretty straightforward. We're just plotting points. -2, -2, 1, 2, 1, 2, right here. 6, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, right here. And we're just going to connect the dots. Doesn't have to be perfect, but something like that. 2, -2, 1, 2, 3, 4, 5, 6, 1, 2. Good. Find the midpoint. Okay, so we need to find the middle of this. There's a formula for that. It is x1 plus x2 over 2, right? The average of the x values and then the average of the y values. Okay, so that would just be -2 plus 6 over 2, and then -2 and 4 over 2. So that's -4. Sorry, that's 4 over 2. That's just 2, and then here that's 2 over 2, which is 1. 2, 1, and then you can visually look. Does that look at the middle? Yeah, it looks like the middle. Looks good. We got it. And then we want to find the length of half the line segment. So half line segment, that would be like this region here, right? Like the length of this or the length of this. There's different ways you could do it, but here, this is where you want to use the distance formula. And I'm just going to use the distance formula of this specific region. So my 2 points that I want to find the distance between are, I want to find the difference between -2, -2, and 2, 1. And so you got into the distance formula to do that. So the distance between these two will equal root x2 minus x1 quantity squared plus quantity y2 minus y1 squared. Okay? It's Pythagorean theorem. Okay. So x2 minus x1, that would be 2 minus -2, so that would be, I'll write it out, 2 minus -2 squared plus y2 minus y1, that's 1 minus -2 squared. This is 4, so that's 16, and then that's a 9, so that's, sorry, that's a 3, so it's a 9, so it's root 16 plus 9, that's root 25, so the distance is 5. And again, you can kind of sanity check yourself, look up ahead. Does this roughly look like 5 units? Yeah, it does, right? So, just a good idea to double check by going back to the picture. Also, like if we look at this, it's a 3, 4, 5. It's a special triangle, right? 3 squared plus 4 squared equals 5 squared. It's a special right triangle, so that was nice too. Okay, keep going. Factoring, guys, so important. Like I keep saying this over and over again, but factoring is just one of those important skills you need to be successful in calculus. To solve by factoring, first we set it equal to 0, so we're going to move these over, right? Plus 13x and plus the 3. So we're going to get 3x squared plus 13x plus 4. And there's different ways you can, I mean, everyone has their own preference on how to solve by factoring. I'm going to do ACB because that's what a lot of you know. So ACB would be 12 on top, 3 times 4 is 12, and 13 on bottom, two numbers, multiply and add, be 12 and 1. We're going to split this guy up. Remember, these are not your factors. Most common mistake. I'd love not to see that mistake on the test. These are not your factors. You split up this 13 into 12x and x, and then we have 3x squared plus 12x plus x plus 4. Greatest common factor comes out, 3x, x plus 4, plus, and then just a 1, right, x plus 4, and that's the placeholder. And we're happy because these are the same, right? These are the same, so we're factoring the x plus 4 out of there. So then we'd have 3x plus 1 times x plus 4 equals 0. We're going to set each of these equations equal to 0, so x plus 4 equals 0 means that x would equal negative 4. It's one of your solutions, and then 3x plus 1 equals 0, that means that x would equal negative 1/3. Okay, that's it. This is an inequality, so we solve these really the same way that we solve equations. Get b alone on one side. So this one has some distributing, has a few extra steps, but in general it's going to be, so it's negative 6, distribute the negative 5, so we're going to have plus 40b plus 25 greater than or equal to 6b plus, and then 5 plus 2 is 7, so just go ahead and combine that. Here, these two go together, so we have 40b plus 19 is greater than or equal to 6b plus 7, minus 6b from both sides. The 6 and the b look so similar. And then I'll minus 19 both sides here. This will get me 34b is greater than or equal to negative 12. And then last step, just divide by 34 both sides. So then b is greater than or equal to, let's see if we can simplify this. This is going to be negative 6 over 17. Okay. All right, we got another graph in one. Plotting points, it's pretty easy. Negative 1, negative 2, right here. 3, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6. Connect the dots. Find the slope. Okay, so, you know, on, I think, section P.4, we actually didn't take that second page of notes. That is not going to be on the test. So nothing from that page of notes is going to be on the test. I never sent you homework from that, so nothing like that will be on there. But we did cover point slope form, we did cover slope intercept form, and we did cover how to find slope. So that will be on the test, or could be on the test. So remember, slope is a rise of a run. 1, 2, 3, 4. I mean, we can do a graphic, you know, kind of visually, graphically. 4 is the run. 1, 2, 3, 4, 5, 6, 7, 8 is the rise, right? So you could also write it with an equation, you know, y2 minus y1 over x2 minus x1. But what you're going to get is 8 over 4, which is going to be 2. Write an equation in point slope form that intersects 2 points. Remember that y minus y1 equals x minus x1. So that would be y minus, I'm going to choose 3, 6 as my point, but y minus 6 equals 2x minus 3. And then convert to slope intercept form. That just means get y alone. So we're going to take that same equation. I'm going to just rewrite it. We're going to distribute the 2. So y minus 6 equals 2x minus 6. And then we're just going to add 6 to both sides. So y equals 2x. Okay? And if you look at the picture, I mean, that makes sense. Like, that's what it looks like, y equals 2x. So just always kind of sanity check yourself, like look back at the image. Okay, just 4 more problems. Here we go. It's not too long. All right, solve for the roots in the simplest form by completing the square. So this is asking us to complete the square. Let's do it. Okay, so first step, clear the constant. Minus 76 both sides. I'm going to rewrite it. 4x squared minus 64x equals negative 76. Now, I think this might be, our next step is to divide by 4. Everything is divided by 4, so that would be, I'm just going to write that out. So everything's going to be divided by 4. So that's going to be x squared. X squared minus 16x equals, and it's 76 divided by 4 is 19. Okay. Then we're going to add b over 2 squared to both sides. So remember, my b is negative 16. b over 2, well, that's negative 8. And then b over 2 squared is 64. So we're going to add 64 to both sides. So we get x squared minus 16x plus 64 equals, and then 64 minus 19, just make sure I don't make a mistake. I got 45. Okay. Now we can rewrite this as a perfect square, right? It's going to be x minus 8 quantity squared equals 45. Why is it minus 8? Well, that's a pattern of perfect squares, is that this value here is always b over 2. So 8 is b over, that's our b over 2 from above here. That's where that comes from. And you could also test this by like foiling that out and expanding that out. You'd see that x minus 8 squared is that. Or you could even like factor over here 64 and negative 16. Two numbers that multiply to 64 add to get negative 16. That's negative 8 and negative 8. That's where that's coming from. Okay. Okay, now we're going to root both sides. This is not a perfect square on the right, but that's okay. Don't get scared by that. We have x minus 8 equals plus minus root 45. That means we have these two equations, x minus 8 equals root 45, and x minus 8 equals negative root 45. That would be x equals root 45 plus 8, and x equals negative root 45 plus 8. We want to write this in simplest form, though. So if you remember from simplifying radicals, you want to look for the biggest perfect square that's inside 45, and that would be 9, right? This is the same as root 9 times root 5. So what we have is x equals 3 root 5 plus 8, and then the same thing here, x equals negative 3 root 5 plus 8. That's it, completing the square. Okay, quadratic formula. Okay. You said equals 0 as normal, 15z squared minus 2z, it might be minus 1, minus 2z minus 1 equals 0. So my a is 15, my b is negative 2, and then my c is negative 1. Okay, so then we just plug it into the formula. You gotta know it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Plug it in. X equals 2, right? Double negative, plus or minus negative 2 quantity squared minus 4 times 15 times negative 1 all over 30. Continuing. That's 2 plus or minus, that's 4. This is 60, right? But then the positive, it's going to be plus. So it's actually going to be plus or minus root 64, which is nice because that's a perfect square, right? That's 4. Then it's minus 4 times 15 is 60, but then times negative 1 it's going to be plus 60. Okay? All over 30. That's 2 plus or minus 8 over 30. So it's 10 over 30. And then 6 over 30, so that's x equals 1/3 and 1/5. Okay, last page. Solve the following inequality algebraically. Okay, first, it's a little bit trickier than the simple version of this, but we solve the same way. Remember, you've got some absolute value, and it's like a v, right? And you want to figure out where that v is above or below a certain value. Right now, though, it's not in a form that we like. We need to solve this, basically. So I'm going to write it out. Negative 5 absolute value, 3 minus 3x minus 2 equals negative 62, and we're going to solve this. We're going to add 2 to both sides. We're going to get negative 5 3 minus 3x absolute value equals negative 60. And then I'll divide both sides by negative 5. We're going to get absolute value 3 minus 3x equals 12. Then I have my two equations, right? 3 minus 3x equals 12, or 3 minus 3x could have equaled negative 12. This, I'm going to add 3x, and I'm going to subtract 12. So that's going to get me negative 9 equals 3x, so negative 3 equals x. Here I'll do the same thing. I'm going to add 3x, add the 12, 15 equals 3x, so 5 equals x. So now I have a number line. I know that it's negative 3 here, I know that it's 5 here, and we got to test which one is which. So let's take like a 10, right? Let's plug in a 10 into this original, right? So we have negative 5 times, I'm going to write it down here. So we have negative 5 times the absolute value of 3 minus 30, that'd be negative 27, minus 2, is that less than negative 62? Well, you can see just by looking at it, yes, this is less than negative 62, right? Because we have negative 5 times positive 27 minus 2. This is definitely less than negative 62, right? So this is true. So this would be a true statement here, okay? Let's plug in a 0, because that's the middle here. So if we plug in a 0, we would just get negative 5 times 3, which is negative 15, minus 2. That is not less than 62, so it would fail here. And then we can plug in like a negative 10, right? So then we have negative 5 times 3 plus 30 minus 2. Again, this is definitely going to be smaller than negative 62. You can see just by looking at it, like negative 5 times 33 is a big negative number, so that would be true. So your final answer would be from negative infinity to negative 3, or 5 to infinity. And it's because it's open, it's a less than sign here, that's why we're open here. Okay, very last question. Solve the following inequality algebraically. So again, you solve this like an equation. 5x squared plus 7x minus 1 equals 10x plus 1. We're going to set it equals 0. Five x squared minus 3x minus 2 equals 0. And then we are going to factor this, or we're going to solve this. I'm going to solve this by factoring. So this is kind of a longer problem. It's going to be negative 10 over negative 3. Two numbers that multiply to negative 10, add to get negative 3. That's negative 5 and 2. So we split this up into negative 5x and 2x. And 5x squared here. So then we'll take out a 5x. And then we'll take out a 2. And so it will be 5x plus 2, x minus 1. So my solutions are x equals negative 2/5 and x equals 1. Alright, so we put the one down, 1, negative 2/5, and then we plug in, right? So like plug in a 0. You can take a 0, plug back into the original. If you plug in a 0 here, you're going to get negative 1 is less than or equal to 1. Yes, that's true. So we would check that. Okay, plug in like a 10, right? I like 10. It's like a nice number to deal with. Well, that's 101 on one side, but then you got like 570 or 569 on the other. That's not, like, that is not less than, so not true. Let me be better about this and really write it out. It would be, again, if I plug it in a 0, that would get me negative 1 is less than or equal to 1, which is true. If I plugged in a 10, I would get that it's 500 plus 70 minus 1 is less than 100 plus 1. That's false, less than or equal to. So that's why we have that. And then if I plugged in a negative 10, that would be, again, 500 minus 70 minus 1 is less than or equal to negative 100 plus 1. That is also not true, right? So that would be false. So my solution would be everything from negative 2/5 to 1. That's the final answer. All right. Hopefully that was helpful. Come visit me in office hours, and I'll see you soon.